In this video, we're going to talk about deducing the structure of an unknown molecule C2H6O. Now in the video, you can wait till we get to the data in the table, and then you can do this yourself. And I fully encourage you to do this yourself before I explain the answer. Okay, but it's really important that you've seen the hydrogen environments and N+1 rule video first, and that you have an understanding of Proton NMR before you do these examples. Also, these are in order of variety and therefore difficulty. So it's simpler at number 1 than it is at number, for example, 14. Okay, because there are many examples for you to do in these videos. So let's get on with doing our unknown molecule C2H6O. Now, it's always worth, when you look at these things, to have a little idea, a little guess, first of all, to see whereabouts you think it might be. So, for example, this is very likely to be an alcohol because it's so simple. But let's have a look, shall we? So we'll start at our NMR, and let's look at what peaks we've got. So that looks like a triplet. So let's zoom in. Yes, it is. This is a singlet. You can see it's just one single line. And then we can see that one there, not a very clear peak, but we expand it out, and it is a quartet. Then we go over there with our ruler, if we're doing it on paper, and we find out exactly where our chemical shifts are. So they are 0.9, 2.3, and 3.3. We then write down what splitting we've seen. So we know we had a triplet, a singlet, and a quartet. And we copy down our relative peak areas, which is 3 and 1 and 2. Now, we've only got 2 carbons and 6 hydrogens. So we know one of these must not be a hydrogen on a carbon. So that kind of gives away that hydrogen must be on an oxygen, okay? Because it can't be on the carbon because there's only 2 carbons. And it also makes sense here, if you look, there's a 3 here, and there's a 2 here. So this is probably a CH3, this is probably a CH2. But before we do that, let's look at the coupling, and let's always explain, whenever we do this, explain one of the peaks coupling or peak splitting, because sometimes you get a mark for that. So we have a triplet here, that means n+1 equals 3, and so 3 minus 1 equals n, which means I have 2 hydrogens on the adjacent carbon. So therefore, for example, the adjacent one to the triplet, so the adjacent one to a triplet must be a CH2. So, for example, this triplet means if I know this is a triplet, I know that this one, for example, is going to be a CH2 because I know these are the 2 with the carbons. But anyway, let's go through. So, if that is the case, 3 hydrogen environments, and let's start going through. So CH3, OH, remember, we only have 2 carbons. Because we only have 2 carbons, we know that must be a CH2, that must be a CH3. And we also know, because of the N+1 rule, okay, that this CH3, which is the triplet, must be next to the CH2, which is the quartet. Okay, because there's 2 adjacent hydrogens. Therefore, 2 adjacent hydrogens, they must be bonded together. Okay, and the only reason I've put the OH on here is because you can actually also look at the data sheet and see that CHO is on the data sheet, so you can get it from the data sheet as well. The only one you can't really determine by the data sheet is the OH, because the OH is over such a wide range. So if you go through this, this kind of makes sense. It's a triplet, which means it's next to something with 2 hydrogens on it, which means the CH3 is next to the CH2. And this is a quartet, which means it must be next to the CH3, because 3 plus 1 equals 4. Quartet has 3 hydrogens on the adjacent carbon, so those 2 are connected, and therefore the answer to this all is going to be that this is ethanol. Okay, so your CH3, CH2, OH. Now, what do we actually learn from this? Now, the most important thing from this, and each one of these videos has a lesson, is this triplet and this quartet. Okay, this triplet and this quartet. Now, a triplet with a relative peak area of 3, okay, and a quartet with a relative peak area of 2 is indicative of an ethyl group. So if you ever see those next to each other, it's an ethyl group. And it's an ethyl group that is not peak splitting anything else here. So there's not a CH2 here. There must be something that's stopping any further peak splitting, for example, like an OH or an NH or something like that. Okay, so really important, if you see this triplet and this quartet, that you know that's more than likely going to be an ethyl group. And that's the main learning we want for this video. Recognise that ethyl group, recognise seeing a triplet, recognise seeing a quartet. If you see them, okay, and it's usually the triplet first and then it's the quartet. Remember, we go from right to left, so it'll be the triplet here, then the quartet. That is your ethyl group.